Still look good? Okay. Alright, welcome back. We're trying to finish up this Geometry Honors Semester 1 exam review. We're on 71. Everybody's favorite proofs. Okay. So remember, what you're going to do first is mark up your picture, right?
Yes.
Squiggly.
They tell us that AD is parallel to BC. So I know AD is parallel to BC. Put in arrows, yes?
Yes.
Why?
Because that means
Let's do
parallel.
that. And AD is congruent to BC. It wants to prove that AB is parallel to CD. So prove the opposite side is parallel, right? Now, let's see what else can we mark. Squiggly, somebody said, right?
Yes.
Mark a squiggly. Now, remember I told you there's only one reason they're going to tell you parallel lines from now on. So for your transversal, and your alternating interior, corresponding, that kind of stuff, right? So if there's my parallel lines, if I use this as a transversal, DB, what would that tell me about this angle and this angle? Alternate interior angles will be congruent, yeah? So, now, so do we have enough to prove the two triangles congruent?
Yes. Yes. Side angle side.
Side angle side, right? I got this side, the angle, and this side. The angle's right in between the two sides, right? Same thing over here. So I can prove this triangle is congruent to this triangle by side angle side. Once I do that, I can say, can't I say that this angle has to be congruent to this angle?
Yeah.
By CP, CTC?
Yep.
Right? Corresponding parts of congruent triangles? Or once I got that, those would be alternating interior angles for these lines. And I just proved that alternating interior angles are congruent, so that means the lines must be parallel. Okay? Alright, so let's write it up. So AD is parallel to BC, given. So right from this, let's go ahead and mention that our angles are congruent, right? Because they're alternating interior, right? Because while we need parallel lines, then we can do that. So let's say angle ADB is congruent to angle CBD by alternating interior angles. And then we'll do the other given, AD is congruent to BC, given, and DB is congruent to DB. What reason can I give for DB is congruent to DB? Squiggly's not a reason. There's no like that on your reflexive, right? Alright, so now I've got an angle and then the two sides, so we're ready to prove the triangles. So triangle ADB, okay, triangle ADB is congruent to triangle, what? ADB is congruent to what triangle? It has to be CBD. CBD by, we said what? Side angle side? Side angle side? Okay, so now I need this angle and this angle to be congruent, and they are the corresponding parts, right? So angle, let's go CDB is congruent to angle ABD by CPCTC. And then once I prove those congruent, then AB must be parallel to DC by the converse of alternating interior angles.
Don't understand.
Tell me what you don't understand. You had to understand some of it.
Oh, I understand to the reflexive part.
Yeah.
The
And
here?
then this, no, side angle side. I
Side angle
understand
side.
that, and then the rest, the last part I don't understand.
Okay, well look at this congruent statement I said.
Mhm.
Angle ADB is this top triangle up here, right?
Yeah.
And this would be the bottom triangle. Angle angle B in the top triangle would have to be congruent to what? Angle D in the bottom, right? Those are corresponding angles, the way we wrote it.
Mhm.
They have to be congruent, right?
Yeah.
Because we proved the triangle's congruent. And we know that the corresponding parts of congruent triangles are congruent.
Okay.
Okay? Now, once these are congruent, we got this line and this line. This will be a transversal coming through there. This angle and this angle would be alternating interior, right?
Mhm.
Well, if the alternating interior says if lines are parallel, then the alternating interior angles are congruent. But we're coming at it backwards. We're saying if the alternating interior angles are congruent, then the lines are parallel. See how we did the converse of it?
Okay.
Yeah.
I didn't understand what
We're doing the converse of it, yeah. We're starting with congruent angles, therefore the lines are parallel.
Okay.
All right, good. I don't think you'll see a proof. I think the proof there might be one or two proofs, and I think they'll be easy.
Okay.
Okay? I think it'll be like prove the two triangles are congruent, and then basically all the sides will be congruent. You know what I mean? And then you'll be done.
So like the proofs we did at the beginning of the year, like I was gold with those. That one all this and
I mean, we need to practice the hard ones. That way we can see an easy one. You're like, oh, this is easy. You know what I mean? All right, so a triangle with sides 12, 20, and 10 is, and then a triangle with sides 8, 15, 16 is. Okay, so what's Pythagorean theorem?
A squared plus
B squared equals C squared.
And if you switch it, what would it be? C squared equals.
A squared plus B.
Okay, so that's how you do these. I want you to do these. Let's see, 12, 20, and 10. Number 72. So C squared equals A squared plus B squared. So the C is always the biggest side, right? We've got 12, 20, and 10. So the 20 has to be our C. So put the 20 in. It equals 10 squared plus 12 squared, right? What's 20 squared? 400. 10 squared is 100. And 12 squared is
144.
144. So I got 400 on the left. And on the right I've got 244. Okay, so what sign goes here? Not equals anymore.
Not
Unequal.
Greater than, right? 400 is greater than 244, right? So listen, when you hear the word greater, do you think of obtuse or acute? Obtuse, that's what this is. Okay? Now, if you did it the regular way, the 244 would be over here, right? And the 400 would be over here, so you'd have to put a less than sign. Less than doesn't go with it, obtuse. That's why you switch it. Okay? So let's do, go
What
ahead.
tells you to switch it?
Huh?
What makes you switch it?
This kind of problem. You know what I would do is always do C squared equals A squared plus B squared. Then you don't have to worry about it.
Okay.
Because it'll always work. If you're answering a question like this, it'll make no sense.
Okay.
All right, so 73. They give us sides of 8, 15, and 16. So C squared equals A squared plus B squared. So I got 16 squared equals 8 squared plus 15 squared. Don't forget the C is always the biggest one. So 16 squared is
256.
256, very good. 64 plus 225.
Yes.
So 256 on the left and 289 on the right. What sign goes here? Less than. So it's acute. Okay? Does that make sense?
Cute.
Alright, 74.
That up, I don't know.
74 is not going to be on your exam. Cross that off.
What is 74?
Did this get taken away because of the?
Yeah, it's one of the things here. Alright, 75. Let's figure out the angles of this triangle here. If this one's 140, what is this one here? 40? If this is 60, what's this here? 20, right? So now what's the larger angle? 40 plus 20 is 60. 120? Okay.
Wait, what is that? Wait, how do you get 40 these?
Aren't these a linear pair? If this extends out, right? Together they have to equal 180,
Oh, okay.
right? Alright, so describe the triangle. Is it an acute triangle? All the angles would have to be less than 90. It's not. Is it obtuse? Yeah. One angle's larger than 90, so it's obtuse. Is it a right triangle?
No.
No. Is it equilateral? No. Is it scaling? What's scaling?
No.
What's scaling?
But they're all different.
All sides are different.
Yeah.
So it is here.
It is scaling.
It is not isosceles.
Isosceles, no.
Not isosceles.
Enigmatic, what?
I don't know what the hell it is. It's not that.
We don't need it.
Do you remember?
Watch it actually be that.
No.
Maybe they just put it on there to compare.
I think they just put a make it later.
Enigmatic.
So we want to Google it?
I mean,
Alright, Google it. Let's see what's up.
What is enigmatic triangle? Enigmatic. Hey! Stuff about diabetes came up. What?
difficult to interpret or understand.
I got
That's how I
diabetes.
describe it.
Yes.
No, we got this triangle figured out. It's not difficult. Alright, so we'll stop there.
Alright.
Hope you all have a great day. We'll see you on the next video.
Don't forget to like and subscribe.